This is my 6th video lesson for the unit ionic bond. In this lesson, we'll be analyzing the properties of ionic compounds. So go to page 19 in the class packet. For motivation, list all or any properties of ionic compounds you know. Think of NaCl as a reference. Learning target. At the end of the lesson, I'll be able to analyze the structure of ionic compounds to explain its properties. There will be a homework number 6 Junipod based off this lesson. There will also be a quiz Junipod based off PowerPoints 4, 5, and 6. So from theme number 1, structure influences property. So in order to explain and figure out the properties of ionic compound, you need to first get the structure. So we have sodium ion bonding with chloride ion. Let's say we have another sodium ion. Which ion would it bond with? So from theme number 2, opposites attract. So sodium is going to bond with chloride. What if we have another chloride ion? Which ion is going to bond with? So it's going to bond with the sodium. So if there's more ions, they will continue the ionic bond. So all ionic compounds have a structure like this. Notice the repetitive nature in the arrangement of these ions. This is known as a crystal lattice. It's a symmetrical three-dimensional repetitive arrangement of ions inside a crystal. So if you have more ions, your crystal lattice can extend forever. So it repeats as far as the crystal extends. It's indefinite. Now we are going to compare the difference between a lattice and a molecule. So a molecule, just to review, is a particle made up of atoms bonding together. It is the smallest unit of a compound. So the question is, why are ionic compounds not considered molecules? So you should know that ionic compounds have a crystal lattice structure. So why are they not considered molecules? Ionic compounds are not particles. If you recall from Unit 1, particles are one unit of matter. There is no lone molecule or particle of NaCl, but rather an indefinite crystal with a fixed ratio. So here's an example. We have 1,000 sodium ions and 1,000 chlorine ions. It's still considered NaCl. If we look at the crystal lattice structure of NaCl, notice there's a lot of ions. There could be hundreds of sodium and chloride ions, but they're always at a 1-to-1 ratio. So the number of ions does not affect the chemical formula, even though there might be hundreds of chloride and sodium ions. If we look at the crystal lattice, there is no smallest unit. That's why ionic compounds are not considered molecules. The smallest unit is NaCl. That's why we write the formula as NaCl. If you look at water, which is considered a molecule, the number of elements matter. Notice for water, it's always 2 hydrogens and 1 oxygen. If you had a chemical formula that was H4O2, it is the same ratio as H2O, but it is not water. It is a different substance. There could be hundreds of sodium and chloride ions, but as long as the sodium and chloride are in 1-to-1 ratio, it always will be considered NaCl. It will never be Na100 and Cl100. The actual amount of ions in the salt crystal does not matter. What matters is the ratio of those ions for ionic compounds. For molecule, what matters is the amount of atoms per element that is actually present in the substance. So that's the key difference between a molecule and a crystal lattice. So ionic compounds, since they have this type of structure, are not considered molecules. Learning check number 1. A crystal lattice is a what? Pause the video and resume once you have the answer. So this is a definition question, so the best answer is choice 2. A three-dimensional pattern showing the arrangement of crystal particles. So a crystal lattice does not have to be ions in particular, as long as the particles within the crystal are arranged in a three-dimensional pattern. Learning check number 2. The crystal lattice of potassium chloride is composed of what? Pause the video and resume once you have the answer. So we know potassium chloride is an ionic compound because potassium is a metal, chloride is a nonmetal. So there must be ions. So the best answer is choice 4. Now that we got the structure for ionic compounds, we can now identify and explain each of the properties. So the first property is that ionic compound exists as a solid crystal lattice at STP. So that's basically the structure of ionic compounds. At STP, ionic compounds are hard solids. So why is that? If you look at the crystal lattice structure, the ions are very close together because they are attracted to each other. And because they're attracted to each other, they are packed together in a rigid pattern. Since each ion have a lot of ionic bond attraction, it's very difficult to move the ions. Therefore, the material is hard. Ionic compounds have high melting and boiling points. So why is that? If we look at NaCl, it has a melting point of 801 degrees Celsius. That's quite high. So first you have to compare the properties of solids and liquids. In liquids, the particles and ions can move on top of each other, but for solids, they're stuck together. So in order for a solid ionic compound to become a liquid, you need to break all these ionic bonds. So recall from the previous unit, breaking exort releases form. In order to break all these bonds, you need to apply energy. That's why the temperature is so high for the melting point. So ionic compounds are held together by ionic bonds, so which are really strong. So a lot of energy is needed or absorbed to break all those bonds. Solid ionic compounds are brittle. Brittle means it breaks easily. If you ever used salt before, you notice that even though salt is a hard solid, it breaks quite easily in your hands. So why is that? If you were to take a hammer and hit this salt crystal, notice what happens. Notice that the ions are offsetted. It's no longer opposite charge attraction, but same charge repulsion. Now I want you to watch a video about the brittleness of ionic compounds. The link to the video will be in the descriptions. Once you watch the video, resume this one. Let's summarize why solid ionic compounds are brittle. So ions in the lattice are held together in a definite position. However, the lattice structure can shift with a sharp force causing repulsion. So here's a very good diagram illustrating this. Learning trick number 3. A hard substance that has a high melting point is a brittle as a solid. This substance can be what? Pause the video and resume once you have the answer. So the answer has to be an ionic compound. So the only ionic compound here is choice 1 because that's a metal with a non-metal. Solid ionic compounds are poor conductors of electricity. So your table salt will not conduct electricity. So if you look at the structure of this lattice, it has ions. It has charged particles. Shouldn't that conduct electricity? So before we answer this question, you must first ask yourself, why does anything conduct electricity? Why would a piece of metal conduct electricity, but a piece of wood would not? So in order for anything to conduct electricity, the charged particles must move from one place to another place because electric charge is transferred by physically moving charged particles. For example, electrons or ions. In the case of an ionic compound in a solid state, the ions cannot move because they're in a fixed lattice structure. So even though they have ions, they are not moving, so they cannot transfer any electric charge. The next property is that ionic compounds are soluble in water to some degree. So why is that? The next property is ionic compounds are soluble in water to some degree. So all of you should know that salt dissolves in water. So why is that? If you notice from this GIF, when salt is dropped into a glass of water, the water molecule break up the lattice structure. In the future, we will discuss how is water doing that, but for now, it is because of intermolecular forces. So if you look at this diagram, water is breaking up the crystal lattice by interacting with each ion. So we will discuss in Unit 5C how does this work. So the solubility of ionic compounds can range from very soluble to barely soluble, which is insoluble. The degree can vary based on conditions like temperature. In the next property, if the ionic compound is a liquid or dissolved in water, then it will conduct electricity. So why is that? If you recall, for ionic compounds in the solid state, the ions cannot move. They're fixed in a lattice structure. But if you melt or dissolve the ionic compounds, then the ions can move. And since they can move now, they can carry a charge. If you see the word molten, it basically means your ionic compound has melted, is in the liquid state. Now I want you to watch a video of an experiment that if you melt an ionic compound, it will conduct electricity. The link to the video will be in the descriptions. Once you watch the video, resume this video. So I assume everybody has watched the video. So when ionic compounds are dissolved in water, they are also good conductors of electricity. This is known as a good electrolyte. So an electrolyte is a substance that when dissolved in water conducts an electrical current. So ionic compounds are good electrolytes. So let's summarize. The reason why liquid ionic compounds conduct electricity is because the ions are moving and flowing around. For aqueous solutions, ions are dissolved in water. Therefore, the ions can move in water, thus conduct electricity. So as long as ions or charged particles are moving, it can conduct electricity. Learning check number 4. A solid sample of a compound and a liquid sample of a compound of the same compound are tested for electrical conductivity. Which test conclusion indicates that the compound is ionic? Pause the video and resume once you have the answer. So we know for ionic compound, the solid is a poor conductor while liquid is a good conductor. So the answer is choice 4. Learning check number 5. Solid sodium chloride, NaCl, is a poor conductor of electricity, but it is a good conductor of electricity when melted or dissolved in water. Which statement is true? Pause the video and resume once you have the answer. Okay, so let's go over the answers. So molten sodium chloride consists of molecules. So that's wrong. It consists of ions. When sodium chloride dissolves, the attractive force of water pulls apart the ionic lattice of the solid sodium chloride. That's true. So the answer is choice 2. So this is a summary slide listing out all the properties of ionic compounds. Make sure you are able to identify each one and explain it for the exam and other regions. So this concludes the video lesson for today. Remember to do the junior part homework and quiz.